We are covering permeability and Darcy's law, a key topic in the geotechnical engineering section of the FE civil exam. You will find the relevant equations in the geotechnical section of your NCEES FE reference handbook. Let's start with the foundational equation, Darcy's law, which is given as Q equals K times I times A. Here, Q is the volumetric flow rate, for example, in cubic feet per second. K is the coefficient of permeability or hydraulic conductivity. I is the hydraulic gradient, and A is the cross-sectional area perpendicular to the flow. The exam will test your ability to manipulate this simple formula, often through tricky units or misinterpreting the variables. The coefficient of permeability, K, depends on the soil type. The handbook provides typical values, showing that gravel is highly permeable, while clay is practically impermeable. A common exam problem might give you dimensions in feet, but a K value in centimeters per second. You must be sharp with your unit conversions, as distractor answers will almost certainly include results from incorrect conversions. Next is the hydraulic gradient, I, which is the head loss, delta H, divided by the length of the flow path, L. Imagine a permeameter test in the lab. You have a soil sample of length L, and the water level difference between the inlet and outlet is delta H. The gradient I is simply that difference divided by the length. A frequent mistake is confusing the length of the sample with the elevation. The length L is the distance the water has to travel through the soil. Finally, the area, A, is the total cross-sectional area of the soil sample that the flow is passing through. For two-dimensional seepage, like under a concrete dam, we use flow nets. The formula for total flow, Q, is K times H times the ratio of NF over ND. H is the total head loss across the entire system. For instance, the difference in water level upstream and downstream of the dam. NF is the number of flow channels, which are the spaces between the flow lines. ND is the number of equipotential drops, which are the spaces between equipotential lines. An exam trap here is miscounting these values. Remember to count the spaces, not the lines. Also, this equation calculates the flow per unit width into the page. So if the question gives a dam length of, say, 100 meters, you must multiply your result by 100 to get the total flow. A memorable phrase to keep the main formula straight is quiet kids in an area. This can help you recall Q equals KIA. The biggest exam challenge with these problems isn't the complexity of the formulas, but the meticulous attention to detail required for units, variable definitions, and correctly interpreting diagrams. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.